looks like we have this. We have this error that we added in accidentally last time. pinst is undefined, and when we go to this and actually look at the source code, it's inside of P5.js. Store mode and maxes. So there's something. RGB HSL. You know, I wonder if that's a color thing. Did we like go out of bounds in a color? So what did we actually do last time? So in the game, I think we were creating this world here. Right, the world and the trees. We're planning on creating a whole bunch of trees, and we're gonna have a world that draws all the trees, and the world is gonna have all the shared parts that the trees have. So we might have to have like a shared, like a tree shared type thing. But for right now, all the trees are going to have a specific tree velocity. Then we have our list of trees. Then we have our tree class here. So we have a trunk location. Okay, so whereas the trunk location, we're going to have the leaves also, but we're not really going to care about those per se. We only care about them compared to where the trunk is. The width and the height, this is going to be of the trunk. So this might be good to sort of like just mention that. This is trunk width, trunk height, so then we have this color here. So us creating a color, I think this is where we're going wrong. When we create the tree in the main game, in our setup here, here's where we're creating a single tree. We're attempting to do a new P5, a new color, and then sort of like set things based upon that. I don't think that this is working for us. So I think over here, we're gonna need to go back to P5.js, its reference. And we need to look at color and possibly not use their constructor or their factory or whichever function they have here. So we have color here. And just alpha. We might be able to just store these separately. If I look at color. Okay, so I can just call color directly. So instead of this new P5 color, we can say, I want this to be color, and then it's RGB. So 0 red, 255 green, 0 blue. And then, okay, there's fill, stroke, rect. So my guess is we're also going to want essentially alpha, and we'll just set this to something like 100. We don't need these anymore. So then we'll have our color, and then we'll pass in the alpha as well. The tree, we've taken the color, we've taken the alpha. And that means that, okay, we do fill this dot color, and then we're going to do alpha this dot alpha. And hopefully that should not screw everything up for us. Let's find out. Also, we found out that those trunks are really, really small. So we need to make these huge comparisons. So this is position 50, width of 5. This is going to be more like width of, I don't know, 20, and a height of maybe like 150. And if we do that, we're going to come here, hit refresh. We still have the can't access lexical declaration color before initialization. It's in game line 13. So const color equals right. Because I'm overwriting and killing the version of color that's coming with P5.js because it's a global. So we have to change this to be specifically maybe like tree color. That would make it a little bit happier. All right, and there's our color. We have this sort of edge around it too. Oh, we're also getting this console log. I am rolling. I think that's off the player. But anyways, I'll worry about that in a second. This this green here. Now, if I change the alpha to like 50, I don't see that changing very much. If I do even like 0, yeah, I don't think that's being set then, unless like 255 is, yeah, the other side. So this isn't really doing anything for us. At least the alpha isn't. Now I'm taking the alpha after the color, I'm storing it, and I'm trying to set the alpha with this.alpha. How does alpha work? It looks like that's just making it see-through. I thought they would also make it sort of fade a little bit, but maybe not. Maybe it's the full color, but then it's making it so you can see things underneath it, which of course we don't have anything underneath it. Oh, extracts the alpha value from a color or pixel array. That's not what I want. I don't want to extract, I want to set. When I do color, can I do a fourth number? I can. Okay, so there's this fourth alpha. So I could put the alpha in there instead of the alpha like separately. So in game here, so instead of this alpha right there, I'm gonna do color. Let's do 100 right here. And we're gonna go to tree. We no longer need to store you. Don't need to store you. We're certainly not going to do you. You didn't work. Save and... Aha, okay, so this makes it a little bit more of a pale green. And so if I was to go find like a super dark green, RGB, like this, for example, this would be pretty good. This is 0, 100, 0. Oh, right, I could just go lower on here. So if I go even like 50, that should make it really dark green, but sort of pale in how it looks. And so if everything, so initially I was thinking that I could share this and then have the alpha be different across all of the different trees. But since this is part of the same color object, I think now I might as well just say, okay, well, if I have a color and we can make it random about how dark it is. And then we can make it alpha to make it like sort of pretty, like, so we could vary the alpha, vary the color of the green. So we can do const green equals random, and then this will be between the different numbers. So let's do between something like 10 and 100, const alpha tree alpha equals random, and then this one I want maybe between we can just do the same thing, 10 and maybe 50, and then we'll use you here, green and alpha. And so now it's going to be very different every single time that I load that up. I think, do I want alpha to be a higher number to make it more faded? If I do like 200 to 255, yeah, I might have to play with the alpha a little bit later to sort of like see how I want it to be running. Oh, I'm not using it. That's why it's not looking right, tree alpha. Let's go back to 10 to 50. Using the variable that you create might be helpful. It's possible. Yeah, okay, so I can see things are a little bit through it now. And so I might want even something like this to be between like 1 and 10 to make it really like much more, I think much more see-through, because I think 255 is like fully visible, I believe. Alpha value relative to current color range. Default is 0 to 255. Yeah, so we could also lighten up the colors. So green is more between like 50 and 150. All right, so that will give us like a pretty good variety of these colors. Although I do realize that the trunk also is gonna be like, we're probably gonna want that to be some kind of brownish color. But let me worry about like actually how it's gonna display later. So I want to now position these down here. To know exactly where to place them in the world, we're gonna need to know what their heights are. So these are gonna have to be different too. So we'll need to store the height. So const trunk height. Oh no, I am storing them right here, but I'll need them in a variable. So equals, let's say 50 for right now. I'll just do width to be consistent. So this will be the X position, the Y position, the width, so the trunk width, and the trunk height. Now, okay, to calculate the X position, we're gonna want So we're starting the triangle at the, or the rectangle at the top left. We want here plus this to equal the bottom of the screen. So X is going to be the entire height of the window minus trunk height. And then the Y, I suppose that we want to start this at the far right and then have us like moving into a forest maybe. For right now, if I just start it right here, it should just pop down. That did not go down here. Okay, so height. You are, oh, these are X position. I want our Y position to be height minus trunk height. Our X position, I just want to be something like, I don't know, 150. Yeah, that puts it in the correct spot. Okay, so now we want to move this all the way over to the right-hand side of the screen, and then we're going to want the trees sort of move to the left with the player. So, move to the left with the player. That means, should I be doing that or should I be doing like the tops? I think we need to draw the tops too. I don't think it'll be that big of a deal for us. Let's make this a little bit taller to give us a little bit more room. Trunk height, 250, really tall. We can do the movement. That will make it a little bit more interesting. We can move it off to the top of the, off to the right of the screen, and then we need to have the tree. So we're having this trunk location. So that's fine. Oh, it's the world. That's what we're caring about. We have this vector here about how the trees are going to move. And it sounds like this is not the right class to put this in according to the text yesterday. It sounds more like we're going to want to have a shared tree model class. Maybe even a tree physics class that takes in a tree and then does all the physics to it. And if we do that, then this tree won't need quite as many things attached to it. I mean, potentially we wouldn't even need update anymore. We could pass the tree in and it will, the tree physics class will then run. The update is off screen. Oh no, okay, I see now. The class was not for methods, but for properties. Properties that we don't want to necessarily add in. And so that would be like this vector here. Like every tree is gonna have this same exact velocity. And so this is forcing it a little bit because it's only one thing. These objects are pretty light anyways. There's no such thing as a mesh that I'm saving. It's just redrawing these very simple shapes every single time. I don't think P5 allows me to sort of save a shape and then reuse it. That would be really nice if I could. If I could, that would definitely be what I want to do. So in this, if I make, for example, if I make a square, yeah, it just draws it to the screen. It doesn't like return, there's no way to return it, doesn't sound like. I mean, I could create a 3D model, but I don't have the art for that, I don't think. And then begin shape is not. It's still these functions that just, they don't return anything. They just draw it to the screen. So we have our tree. The next thing I want to do, draw triangles on a tree. So let's get a triangle. Okay, so x1, x2, so x1, y1, x2, y2, x3, y3. And that will draw on the shape and fill them in. And the first two arguments specify the first point. Oh, and then it'll auto draw a line back to the first one. I don't need to like specify the first point again. So it looks like they need to go in whatever order I want them to be as well. So in tree and draw, we have this rect. We're also going to have a triangle. So we need to figure out like what our leaves like size is. This dot, I guess those would be like branches size equals, if I want to do something like the trunk width multiplied by like 4. So if I do something like that, then we start maybe above the trunk width by double, maybe even. So in our triangle, our first point, we want this straight in the middle. So that's going to be this dot trunk location plus, oops, sorry about that. That's my other computer. Discord notification. So if you heard that, that was mine. This dot trunk location plus this dot trunk width divided by 2. So that'll give us right in the center. Either we want to go up. So that's the x, and then the y is going to be this dot let's go with the trunk location. Oh, it's trunk location dot x. Trunk location dot y. So that's the beginning of the trunk. Let's go up minus this dot. Maybe we can go the entire trunk, the branches size. I don't know. So if we do that, that's up, and now we want the left one. So this dot, so the x is going to be, we want the middle of it minus like the trunk width. I guess we're just going to the branch's size at this point. But we need the middle of the trunk. And we're doing this calculation enough that maybe the middle of the trunk, so this dot middle of trunk, we can calculate that here. So that would be our trunk location plus, so this dot trunk location dot x plus this dot trunk width divided by 2. Now I can use this. So middle of trunk here. Okay, so we have our middle of the trunk, then we have the just up above the trunk. Then we want middle of the trunk minus the branches size. This is x1, so x1, this is y1, x2. All right, so for y2, I want to put it, let's see, so that was to the left, and I want it to go down a little bit. So this dot, for y, we want essentially the trunk location plus. So trunk location dot y plus this dot branches size. This is y2. Now, the third point, it's going to be the opposite of these two. So this dot middle of the trunk plus this dot branches size x3, this dot trunk location dot y plus this dot branches size y3. Y. Let's find out if it works. Hey, look at that. That's not too bad. That looks like a pretty good like tree there. I mean, it's not going to win any awards for like tree design. I kind of wonder what would happen if I duplicated this triangle. And then I lowered it ever so slightly. So then I just said, okay, trunk location. So the y2 and well, I guess this y1. So minus plus, let's just say like 10. For each of these, we just lowered the y's down a little bit. And so it shows up on top here. That's not terrible looking, I think. We could put a whole bunch of these down. We could create a loop to then, let's see, for we don't really care about this. It's like count equals 0. Count is less than 5. Count plus equals to 1. So if I do this in a loop, we can create sort of like a bunch of these. And with this, so the 3 y's here, we can then plus. I guess in this case, we do want our count to be not where it's used. How about you? Nope. Fine. Just manually calculate you in. All right, we want plus, it's going to be our count times and some arbitrary number like 20. Ajinkya, good morning, hello. Now this triangle can go away. Save that, hit refresh, and we're able to see like, okay. It does look a little bit odd because it's kind of going like we can see them stacking on top of each other. That might be that stroke on the outside. If I before this say no stroke, Yeah, okay, that looks a lot better. So this gives us, I mean, it's a little bit weird of a tree, but it's still very tree visible to us. And then we're gonna want to like set like the trunk color maybe separately than the trunk tree. That'll be fine. If I want to do this and now have it move to the left with everything, we know that the world, we're going to want to draw the tree. We're also going to want to move the tree over to the left. And that's going to be this update function. So if we do update, now the world is holding this tree velocity. I think it kind of makes sense just to like, we could store it here, or we could put this into a tree class. To follow what the flyweight pattern sort of like was, we can make this, I don't know if like tree model was the right one. It was tree something. It was like a tree. Like tree physics, tree movement, tree data. Could do like tree data.js. We go into index, add this in here. And so this is tree data.js. Classes don't do that. They do that. All right. So constructor. I don't necessarily think we pull anything in here. We're just gonna set, okay, this dot. In fact, from our where's our world? From our world, this velocity will now be stored in this tree data. Now, tree data, we need to pass into the world, so it has that. So the world might be in charge of creating this. So we can say this dot tree data equals new tree data. Now we don't need any of that information for draw trees. That will just draw the tree wherever it is right now using its unique information. But we do need this for its actually physics and its movement. So if we have the tree in update, we're gonna have to bring in the tree data. And if we extract this out of it and just say we really want the velocity coming in here, and we know that this is a P5 vector, then our update is going to just update our location using this velocity. So this is going to be this dot trunk location dot, I think it's subtract, and then you're wrong. Whatever type hint you're trying to be, you're not helping our velocity. So subtract the velocity from trunk location, and then our draw should auto update that. And so in the world, we're gonna want a sort of like a run function here. And here we want to this dot trees for each, get a tree, and we're gonna run tree dot, is it update? It's update, and we pass in the velocity. So update, and we need to pass in this specific tree data, which has this tree velocity. So this dot tree data dot tree velocity. I mean, this is a little bit it's super easy to reduce the weight. Like, we're not reducing the weight of the tree objects by very much by doing this. So it's a little bit of a contrived example. I think I'm using contrived correctly there. It's a little bit forced. I think when we get back into Rust, we're going to see a lot bigger value add out of this. Okay, so we have run, world, and so then in the game, we have our world. So here's our world with new trees. In draw, we could have, so if our game is running, we have draw trees, and we also want to do world.run. And let's see if that makes the trees all move. Oh no, we just get an error. This .tree data is undefined. Okay, so in world, line 12, this .tree data is undefined. So new tree data, we have this class here. In our index.html, tree-data is named that. This is tree-data.js. So we have you. I shouldn't need to put you up any further, but I can. Tree-data. So we have a constructor here. So when we call tree data in world, so we call tree data, new it, store it in this tree data. If I do a console log at this point in time, we get tree data. Here I have this tree velocity. So I do have this at this point in time. And also think about this doesn't really need to be a class, does it? Because we're in JavaScript. This could just be an object where I just say, okay, this is const tree data. And this makes a little bit more sense where now we can say our velocity is a create vector of -1, 0. And so if I do that, probably not. All right. So in world, we have tree data. This .tree data equals, and then we're going to do tree data. I think we have to clone it so we don't accidentally like change it in case we ever need the original again. In fact, we don't even need to store this locally, do we? We could just throw in the tree data separately, and world can just be aware of that. Although it is probably better organizationally to pass it through so it's easy for us to like know, and it just doesn't go grab it globally. It does have this. Okay, so let's do tree data is stored in here. I like this more. So if I store this .tree data, then you're going to be just the velocity passed into you. In our main game here, in our setup, we initialize a new world. We also need to pass in tree data like that. And so if I do that, create vector is not defined. So that's over here, create vector. Am I just not doing create vector correct? So that's create vector. Oh, it's the same spelling. So I'm doing this in the wrong location, I think. Oh, you know why? Because I need to set, this is running tree data as soon as it starts up, which is before P5 has initialized. So unfortunately, I can't run create vector at this moment. So I probably need to just store the sort of like just store that vector in its own data structure here. And then we convert that to a vector on initialization. So we can have speed left, like speed x, and this could be -1, speed y is 0. Then in game here, so we have this tree data. Instead of just passing in tree data, we want to pass in we want to create the tree velocity. So this is going to be const tree velocity equals tree data equals create vector. Tree data dot speed x, tree data dot speed y, tree velocity gets passed into there. Our world has just a tree velocity just stored straight in here, and I don't need the velocity off of that. So if I do you're running, and ooh, the trunk moves to the right, along with, and the branches don't move with it. So in our initial tree data, we want speed x is -1. Oh, interesting. And so with tree, when I'm doing update, oh, I want to add, not sub. So add will make it so it moves to the left here, but now we need to make it so that our branches stay with the trunk, because that's like not working for us. So I was hoping that this trunk location would be mutated, because all my, because you know what, middle of trunk is calculated once. I need to calculate this every single time. Maybe like before these loops here. If I do that, now the entire all the branches move with a tree, and it just moves off to the side. So that's perfect. Then I want to start the tree all the way to the right off the screen. And we happen to know that the tree's width here, so we can just go width plus just some arbitrary amount, like trunk width times like 5, or maybe 4, to try to make it so that it's not displaying anymore. And so now if I play, here's these trees, and I think the idea is that because they're moving slower in the background, so it looks like they're farther away from us. So we're getting a little bit of a parallax effect with this, which I think is pretty cool. But now we want to create a whole bunch of these trees. And so that's where this comes in. We have all these trees to create. If I create, do I want to, right here when we initialize, create them? I don't know if we do. I'm thinking maybe we randomly decide if we want to create the tree. Because it's either going to be that, or we create them and then have the location, the X location of where they start, be sort of like randomized way out into the future. And that way we have just, you know, a bunch of, like a forest of trees and then like nothing. Or do we just want it to be kind of random when there's a tree in the background? I don't know. It's an interesting question. If I extract this out into a function, create tree, then all of this stuff is going to have it in here. Now we have this const trees. We're going to need that to be global. Oh, I see. We're going to want the world to create the tree for us and have a method on it where we could just call, hey, time to create a tree, and it creates the tree in the right spot. So the world is going to have a create tree. And what that ends up looking like is, well, we already know it has the const trees in here. So we don't need this for loop. So that goes away. We do know it's going to need a push and create the random sort of colors for it. So we're going to take this out, put it into a whirl in here. So we create the green, we create the alpha, the color, the trunk height, the trunk width. We're going to do this dot trees dot push. Trees, we don't really need trees to be passed in anymore. At this point, now it's just going to be an empty array to begin with. This dot trees dot push, a new tree, the width of the entire world plus the trunk width times 4, so just a magic number for that. We can put this type of stuff into the trunk data or into tree data. So that way we get rid of some of these magic numbers. So that's going to be essentially the branch width, or the branch size is 4. So in world here, instead of this times 4, we're going to do tree data dot branch size. We have this height minus the trunk height, trunk width. Okay, so then this all looks fine. So we're going to create the trees. Then every time we loop through them, so in game, now we have our tree velocity, which sounds like the world is going to be the one that cares about this. So the game doesn't need to care about this at all. So let's extract out this tree velocity too. You don't want this. Our tree velocity is just going to be created in here. So tree velocity, we happen to just know what that is. I don't need to console log this anymore. And then our game, we initialize the world, but we don't need to pass it in anything anymore. We just initialize the world, and then we say, hey, world, draw trees, run, and then maybe like a random generator to tell the world, hey, it's time to create a tree. But maybe under run, the world's also in charge of that too. So we have run through all the trees and update them with the velocity. Well, first of all, will this work? If I just call this dot create tree right here, will we get a tree? We will. Okay, so we get one tree and it moves for us. Don't close the tab. That's not what I wanted to do. I want to go back to you. So that means under run, we can get a random number. So let's say we have a 20% chance that we create a tree in the background. We can store that here. So this dot chance to create tree equals, let's say 0.2. Then if, let's create a random number, so that's just random, that creates a number between 0 and 1. So if that is less than 0 dot, this dot chance to create a tree, then I just want to create a tree. So we're just gonna call this dot create tree. Now we should get a whole bunch of trees showing up. And we do. We get potentially far too many trees. That's a lot of trees. 20% turns out a little bit too high of a chance. Let's switch that down to like 0.02. This is much better looking. I also like the contrast of colors between them, because each of the trees just has a sort of like just very subtly randomized chance of, I mean, it's just a random color to it. So that looks really nice. And I guess the last thing would be to make the trunks a different color. So when we're creating this tree, we're giving it this tree color, and we now know that we want, this is going to be essentially the branch color, and then we're going to also want the trunk color. Now, if we end up having the trunk color always being the same, so that way it's a piece of data that goes in. So another little bit of a forced contrived example of the flyweight pattern here. If I do that, then we only need to pass that in at draw state. We don't need to store it in here. And then we can fill out our color. So let's try that. So in our tree data, we will have the, what would this be? This is gonna be the trunk red. So trunk red. Let's go find like a brown. Dark brown RGB. 66, 37, 24. So 66 trunk brown. I forgot 24, 37, 24. 37, trunk, oh wait, this is green. Blue, what is it, 24? Yes, 24. Okay, so that gives us the color of the trunk that's going to be here. The world, we don't necessarily need to store this anymore, or we can, we create the color here once. So this dot tree trunk color equals color, and so it's gonna be tree data dot trunk RGB, so red, tree data dot trunk green, tree data dot trunk blue. And then when we call draw trees, we're gonna have the trunk color come in here. So fill will be the trunk color. We want no stroke, just at all. Then we have our rectangle. That's going to be our trunk. Then we want to now set the trunk, the leaves color, as it were, which those are up here. So this is a branch color. So if I change you, this is now going to be the branch color. So fill branch color. If I do that, let's see how this works. Object arguments is not a valid color. I think I got object when I try to pass into the color. So that didn't work. So in world, we have this tree data trunk red. We know that this is trunk red, trunk green, trunk blue. That looks fine. So tree data, trunk red, trunk green, trunk blue. So tree trunk color. Oh, we didn't pass it in to draw trees. So this dot tree trunk color. Save that. Let's see if you work any better. Missing formal parameter, world line 9. Oh, I don't want it there. I want it here. Tree trunk color. Save you. I don't see any trees whatsoever. Oh, apparently our chance to create the tree was just really low. Hey, and there's those brown, the brown trunks. So perfect, that's exactly what we wanted. And so once we run into the forest, we're just in the forest forever. And there might be other things you could do to make it more interesting, like, hey, if we're in a forest, it increases the chance of actually, creating a tree. But other than that, I think this is pretty interesting. Now, if we do a review of the flyweight pattern here and like what we did for this, the flyweight, the entire point of the flyweight pattern seems to be reducing the size or the weight of objects. So we chose to create a bunch of trees and put them into the world. In P5.js, this is not as super useful. I don't think that the flyweight pattern actually was helping us here. I think it just made things a little bit more complicated. But what we ended up doing was creating this tree data object that stores the specific variables that all trees share. So all trees have this trunk color. All trees have, this specific branch size and this speed. We initialize and store that here in the world. So we're storing that in one specific place. Now, I could pass that into tree data, like the tree data specifically into each tree we want to create it, and then it would like store them internally, but then I would explode their size again. So the entire point here is that we've separated them out at the expense of all tree data is now inside of a tree. Now the world puts this all together. The world stores all the tree data, and then when it calls the various functions on tree, like for example, we want to draw the tree. Well, here's the color. All trees have this color. You don't need to worry about it. Here is a reference to the color. Go ahead and use it. I know it's a reference because it's I think it's a reference. What does color return? I think that's an object. I guess it might be a string. It completely voids the point if it's not an object, because then we're just copying it over and we're not saving any space. But okay, so we're passing in hopefully a reference to the tree trunk color. In run here, we pass it in a reference to the tree velocity. We definitely know that the tree velocity is a reference because it is an object with X and Y on it. And so it's just using that one tree velocity for all the trees that we create. So even if we create hundreds or thousands of trees, we only need that one velocity. Now, by using the flyweight pattern this way, it forced us to create the world. Otherwise, our game would have to memorize all this stuff and handle it. So the world actually is going to abstract some of that out and just makes it a little bit easier. In fact, we could then remove the draw trees from the game here and have the world handle. Okay, so for run, create the trees, draw the trees. These are together because in P5.js, the draw function is also the update function. In GGEZ, we're probably going to have this be separated out a little bit more. But things will be a little bit different in GGEZ just for a variety of reasons. But we'll get into that probably the next time we do this, this stream, which I'm guessing is going to be Monday. All right. With that being said, that's the flyweight pattern in P5.js and JavaScript. I have a few minutes. Does anybody have any questions about what I did and where it is and how it lives? Something I realized that I didn't do, hey Chantilly, is removing the trees after they go off the screen to the left. That's a potential problem because they'll just move off to the left forever. They'll take up memory forever. We probably want to delete them from the tree array here. So I think we can very easily write a function to remove trees off screen. And so this is, we're gonna just loop through the trees, find the index, and then we want to remove them. We can loop through backwards in the array, and that makes it really easy to sort of like manipulate that array because we're not changing the indexes of previous ones. So it's one of the only times that you ever like do a backwards loop. So let tree index, tree index equals this dot trees dot length -1, so we get the last one. We want our tree index to be greater than or equal to 0. So as long as it's 0 or above, we're fine. And then tree index minus equals to 1. Then I want to check each tree to see if it's like way to the left of the screen. So if, and then I guess let's get the tree, let's extract the tree out to begin with. It's an object, so we're only getting a reference. So const tree equals this dot trees of position tree index. That'll make it a little bit easier for us to work with this. If tree dot, and I think tree has just a trunk location. So if tree dot, we could ask the tree, are you off the left of the screen? That would make it easy in here. So if I just have, oh yeah, is off screen. I already have this method. So we're gonna return, we know 0 is the left of the screen minus whatever. So it's gonna be return this dot trunk location dot x, then add, so to the right of it, if that is the trunk width, so plus the trunk width. Then let's also add in the branches size. So this dot branches size. That way, hopefully, all of those together should make it off the size of the screen. If that is less than 0, then we are off the screen. So is off screen. So if tree dot is off screen, then what I want to do is splice this out of the array. And I think it's splice. So this dot trees dot splice removes elements from an array, and if necessary, okay, so just start and delete count. So then our start is going to be the tree index, and we want to remove 1, and then that should be fine. So if I do that, then in run, we're going to draw trees, we create the trees, we can remove the trees as well. This dot remove trees off screen. And every time we run, we can also just console log the this dot trees dot length. Just sort of see it going there. Let's go find our player. I think we have a console login here somewhere. Or not. I know we have like a role name. Oh, it's in game. We don't need you. So save you all. Hit refresh. And we can see, okay, if we have 4 trees, 5 trees, 8 trees, we have to survive long enough for the trees to move off to the left side of the screen. And then I want to sort of see it not really increase in speed anymore. Also, those trunks are maybe a little bit too dark for these these obstacles. So I would want to like tweak those. Yeah, a lot of trees. All right, so they're moving off the side. Ooh, I saw it go down. Now, then it got a little bit too hard to play anymore. So we'd want to like play with the alpha of the trunk and some other things to like make it a little bit easy to see. But yeah, different shades. Oh yeah, I like that too a lot. So with that, thank you everybody for stopping by. This has been the flyweight pattern in JavaScript. The next time we do the stream, it'll be the flyweight pattern in Rust and GGEZ. And so with that, I'm going to switch